Assalamualaikum. Assalamualaikum. Assalamualaikum warahmatullahi wabarakatuh. We meet again for the third session, the third part of analysis of frame using moment distribution method. Okay, in the two previous session, I have discussed the concept of moment distribution method for frame. Okay, so this time I want to continue with the example. Okay, we go straight to the example. Okay, I don't want to discuss in detail 12.6. Okay, 12.6. I want to choose the next example. This one. Okay, I want to choose this one. Okay, we will change the unit after this. Okay, so this is example 12.7. Okay, this is example 12.7. Determine the moment at each joint of the frame. Okay, the moment at each joint means member and moment. Moment at each joint. Okay, the moment that we calculate using moment distribution method is actually the internal moment that is occur at each joint. Okay, other name for internal moment is member and moment. Member and moment. So here in the question we are asked to determine the moment at each joint of the frame. Okay, the moment of inertia of each member is indicated in the figure. Okay, so okay, this frame as you can see in the screen. Okay, okay, we have diagram A, B and C. Okay, A is equal to B plus C. because this is based on the principle of superposition. Okay, so I want to use this frame to do an example. Okay, so this frame, the beam BC is subjected to a uniformly distributed load. Okay, and the frame is unsymmetry. Due to the geometry of the column. Okay, the geometry, because the column AB and column CD is not constant. Okay, different length. Okay, let's say I want to use this one. Okay, copy this first. Copy. Okay, I want to use 200. It's too big. 20 kilonewton per meter. Okay, A, B, C and D. Okay, length is 10 meter, 12 meter and 15 meter. Okay, I is not constant. Okay, I want to make it constant. Okay, like this. Okay, let's say this is EI. Okay, make it not constant. EI like this. Okay, so this frame will be analyzed. This is side sway frame because the column is unsymmetry. Okay, one column AB is 10 meter and CD is 15 meter. Okay, EI, the column has EI and the beam has 2 EI. The UDL is subjected along BC 20 kilonewton per meter. Okay, it has fixed support at A and pin support at D. Okay, we will analyze this, okay, using moment distribution method. Okay, using moment distribution method, we will calculate the end moment. Calculate end moment. Ayah, cukup. Mas sini. Cukup dah. Main pun moyak. Main. Untuk pergi rapat. Cepat. Main. Masuk. Goncang dulu. Boleh ke? Okay dah, minum. Okay. Okay, remember that we have 4 main steps. We have 4 main steps. Okay, step number 1. Step number 1, we have to calculate the stiffness factor and distribution factor. Stiffness factor and distribution factor. K and distribution factor. Okay, step number 2, we have A and B. We have 2A, 2A. Okay, 2A, we call it as 2, step number 2. Okay, non-sway frame, non-sway frame analysis. Okay, under step number 2, we have A, fixed end moment. We have to calculate fixed end moment due to external load. External load. B, then calculate end moment. End moment, which is called as, the symbol is as M naught. Okay, and C, using the end moment from the table, we will calculate the R value, restraining force. Restraining force. Restraining force R. Okay, restraining force R. Okay, this is step number 2. Step number 2, non-sway frame analysis. Okay, non-sway frame analysis, remember to make this diagram. Okay, this is original diagram. This diagram has combination of sway frame delta and as well as external loading. So we have to analyze non-sway frame analysis by putting the pin support at C. Okay, the frame is tend to sway to right direction. Okay, we assume that the frame is tend to sway to right direction, so we have to put a support at C. Okay, number 2 we will do after this using this diagram. Okay, this is 20. This is 20. So this is A, B, C and D. Okay, so here we have a restraining force which come from the pin support that we put at C. Okay, step number 3. Okay, step number 3, subsway frame. Okay, side sway frame analysis. Okay, step number 3, side sway frame analysis. We are going to analyze the M prime, the end moment M prime. Okay, we have step 3A, FEM due to delta prime. B, we have to calculate M prime end moment. And C, we have to calculate restraining force R prime. Okay, the diagram for step number 3 is this one. A restraining force R prime, the delta prime, okay, like this. Okay, this is step number 3, side sway frame analysis. So the method, yeah.
Madam tutup.
Okay, side sway frame analysis. Okay, so this is step number 3, side sway frame analysis, FEM. Is based on the delta prime. This is the assumption value. This is the assumption. Okay, the assumption value, and after that we will calculate M prime, the end moment M prime, and after that R prime. Okay, this is step number 3. Okay, this is the diagram, the frame that we are going to analyze in step number 3. Okay, table number 2. So this is for table 1. Okay, this is for table 2. Table 1 and table 2. Okay, the first diagram. This is side sway, non-side sway frame. After putting a pin support at C, so this is for table 1. And then for table number 2, we are going to analyze side sway frame. Okay, the frame is tend to sway to right direction due to R prime. Okay, because of R prime. Okay, and due to R prime, okay, they delta prime that exists at position B and C, because B and C can move, A and D cannot move because it is support. Okay, so step number 4, the last step. Okay, so we combine all together using superposition method. We will write the equation superposition method. Okay, the end moment for this one, for the main one, end moment is M final. So this is M final, and M final is equal to M prime, the moment, the end moment from table 1, plus the correction factor R divided by R prime times with M prime. Okay, so basically this is the step. That we need to do. So how we get this? How we get this equation? How we get this? Okay, it is based on the superposition method. Original diagram is like this. This is pin and fixed and pin like this, loading. This is equal to, okay, we put here support so that it cannot move, so it become non-sway frame, plus, so this is R. So to neutralize back, we have to put R in this direction, so that negative R plus R negative r plus r equal to 0. This is 0. Okay, so w, this is w, plus 0 here. Here is 0 equal to this one. Okay, however, we cannot analyze this one. We cannot analyze this directly. Directly cannot. Okay, we cannot analyze this one directly. So what we gonna do is we will analyze an artificial one. Okay, the same, but this one is subjected to r prime. So here is delta. So here will be delta prime, r dengan r prime, delta prime, r prime, delta prime. So if this one is m final, this one is m naught, this one is m, this one is m prime, because r prime produce m prime, r produce m. So we compare together. We compare this. So using principle of superposition. Okay, ni dia punya boundary. So m final is equal to m naught plus m. Okay, m naught plus m. So we interpolate. So how many diagram here? We have here A, B, C, D, right? Okay, it is A equal to B plus C. Okay, so and then we interpolate C and D. Interpolate C and D, we get m divided by r equal to m prime divided by r prime. So this will become m equal to, because only m is unknown. Okay, this become known. This is known value. So we get m is equal to r divided by r prime times m prime. Then this one we substitute into this. So we will get m final is equal to m naught plus r divided by r prime times m. So this will become the equation, this equation. Okay. Okay, so we will start with step number 1. Step number 1, we want to calculate K. Okay, we have 3 elements. We have 3 elements A, B, B, C and C, D. For element number 1, A, B. K, A, B is equal to K, B, A is equal to 4EI over L. L is 10. Okay, 4EI over L, because far end dia fixed. So okay, we get this 0.4 EI. Okay, so member number 2, KBC is actually equal to KCB because stiffness is 4 element. Okay, it is internal member, so 4EI divided by length is, the length is 12. Okay, 1/3 0.333 EI. Okay, 0.333 EI, and we calculate for KCD, which is equal to KDC. This is the same. Actually, we need to write only one, KCD only. Okay, this is okay. By looking at the diagram, the D is pin, so we need to use the formula for and pin. It is 3 EI over L. Okay, yang ni ada 2 times 2, so 0.667. 667 because 2 it is 2 EI. It is 2 EI. Okay, so it is 3 EI divided by 15 by 15. So 3 divided by 15, 1/5, 0.2. EI. Okay, this is step number 1. Member stiffness factor. Member stiffness factor. Okay, we will now using this we will calculate the distribution factor. So distribution factor DF. Okay, DF AB is 0 because of fixed. DF DC is equal to 1 because of pin. Okay, then we will calculate DFBA. It is KBA plus KBA plus KBC. Okay, it is 0.4 divided by total 0.4 plus 0.667. 0.4 divided by 0.4 plus 0.667. We get 0.375. 0.375. EI will be cancelled. So DFBC, since the distribution factor for joint is 1, so it is just enough for doing like this. Okay, distribution factor for BC is 0.625. The total here must be equal to 1. Okay, so we move to the next one, DFCD. DFCD is 0.667. 0.667 divided by 0.827. 0.867. 0.769. 0.769. This is CB. DFCD is 1 minus 0.769 equal to minus 1, 0.231. Okay, 231. So this is the distribution factor. Okay, so next is step number 2. Step 2. Okay, step 2. A, we will calculate fixed end moment. Fixed end moment A. Fixed end moment for member ABC. Okay, fixed end moment for BC is negative WL squared over 12. W is 20. 20. L is 12. L squared over 12. WL squared over 12. kilonewton meter. CB is equal to positive 240 kilonewton meter. Okay, so then this is A. We move to step B. B ni we need to have the table. Okay, the table. Okay, here is member, DF and fixed end moment. DF and fixed end moment. AB, BA, BC, CB, CD, DC. Okay, this is B, this is C, this is D, this is A. Okay, so distribution factor for fixed is 0. Fixed is 0. Pin is 1. And then we have 0.375, 0.375, 0.625, 0.769, 769, 0.231, 231. Okay, fixed end moment negative. Okay, BC, CB. For BC, negative 240, 240. Like this. Okay, we will start with the first distribution. Okay, remember to start with distribution and to end with distribution. Okay, distribution. Okay, this is distribution 1. Okay, so remember that we have to find the total moment at join. Total moment at join. The fixed end moment is not the join moment. Fixed end moment is also the member end moment. The first member end moment in the table is fixed end moment. Okay, but we need to change to join moment, and join moment is always opposite with member end moment. Okay, so for join B, the join moment is positive 240. Okay, join B, the join moment is positive 240. Okay, so positive 240, 240 kali 0.375, we get 90. Okay, we get 90. So here 90. Okay, and 240, get 150. Okay, remember that 1, 2, 3, 4, the total must be 0. The total must be 0 to remain equilibrium condition at support B, because B is rigid joint and B is rigid joint, so the total moment at B is equal to 0. Okay. Okay, let's continue with joint C. The total moment is negative 240. The total moment at joint C is negative 240 because it is opposite with member and moment. So negative 240 we times with the distribution factor 0.769. 0.769. 0.769 times 240. We get 184.56. 184.56. Okay, the balance is 55.44. Okay, because the total must be 0. This one negative. Okay, this one is negative. Okay, because why it must be negative, because the total joint, okay, the member end moment is positive 240. The total the joint moment is opposite, it is negative 240. So negative 240 times 0.769 769, we get a negative 184.56, and 0.231 times negative 240 is 55.44, and the total must be 0. Okay, so the next step after distribution is carry over. We carry the value to opposite join. Okay, carry over means we need to do this. Okay, like this. However, we have to look at to the far end condition to determine the factor. Okay, all join we must divide by 2 or times with 0.5 except for end pin. Here is pin, and the pin, the carry over factor is equal to 0, and pin carry over factor is equal to 0 here. Pin carry over factor is equal to 0, so this one automatic will become 0 because the factor is 0. So this is 45, this is 75. 184.56 divided by 2 is 92.28. Okay, so we continue with the next distribution. This is distribution number 2. Again, okay, A, because the factor is 0, so it is negative 45 times 0. Okay, negative 45 times 0. Okay, for join B, it is negative 92.28. Negative, because this is positive, so this is positive, this is member and moment, so we have to change to join moment. Join moment is opposite, so it is negative 92.28 times 0.375 is equal to negative 334.605. 34 negative 0.605, and 0.625 times negative 92.28 become negative 57.675. Negative 57.675. Okay, we move to C. Negative 75. Negative 75 times 0.769. It is negative 57.675. Okay, then 75. It is 17.325. Okay, so distribution settle. Okay, we move to carry over. Again, we have to carry to opposite join. Carry. Okay, so negative 34.605 divided by 2 is 17.3025. Okay, 57.675 divided by 2. 57.675, it is negative 28.8375. Okay, normally we will use up to 3 decimal point for a quite accurate answer. If we use 2, the answer may be quite different. Okay, in terms of the decimal point. Okay, 675, the same value here, negative 28.8375 as well, because it is the same. Next one, 17.325 divided by 2, it is Okay, it is 88.6625. 6625. Okay, like this. Okay, so we only change the sign at distribution. For carry over, we remain the sign. At distribution, we have to change sign because because of the join moment, which is opposite with member and moment. Okay, next we go to distribution number 3. Distribution number 3. Okay, distribution number 3, it is 28.8375 times with distribution factor 0.375, we get 10. Okay, we get 10. 10.814. Okay, we get 18.023. 28.8375 times 0.769, 22.176. It is 6.661. $28.8375 times 0.23231, 6.661. Okay, okay, we continue. Next one is carry over, then distribution number 4. Carry over, distribution number 5. Okay, carry the value, carry here, carry. Sorry, this one should be 0 because of the factor. Okay, next, carry over, 10.814 divided by 2, 5.407, and then 18.023 divided by 2, it is 9.012. 22.176 divided by 2, it is 11.088. Okay, this one is 0. Okay, we distribute again. 11.088 times distribution factor 0.375, it is negative 4.158. Okay, this is 11.088 kali dengan 0.625, 6.93, negative 6.93. Then 9.012 times 0.769, 6.93. This is negative 6.93. And then 9.012 times 0.231, 2.082. 2.082. Okay, carry over. Here is 0. So it is 4.158 divided by 2, we get negative, remain the sign, 2.079. 6.93 divided by 2, negative 3.465. same, negative 3.465. Okay, then the next distribution 3.465 times 0.375, 1.299, 1.3. This is 1.3. 2.165, 3.465 times 0.769, 2.66, 2.665, 2.665. Positive 0.8. Distribution, we change the sign. Distribution, we change the sign. Okay, then continue. Carry over distribution number 6. Carry over distribution number 7. Okay, we carry the value. Here is 0 because of pin support. Okay, distribution. No, carry over first. 1 or 0.65. This is 0.65. 2.165 divided by 2. 1.083, 2.65 divided by 2, 1.333, and then 0. Okay, distribution again, 1.333 times 0.625, 0.8, negative 0.833, 0.5, 1.083 times 0.769, 0.833, negative 0.833, negative 0.25. Tanah. Carry over. Here is 0.
Hai, buka semua ni. Buka ibu ni. Tuh. Ya, tutup.
Okay, next is carry over 0.833 divided by 2. 0.4165, 0.25, 0.833 divided by 2 is negative 0.4165. Okay, distribution, maybe this is the last distribution, 0.4165 times 0.625. It is positive 0.26, 0.26, 0.4165, 0.156. 0.25 times 0.769, 0.769, Rosak pintu, tutup balik. Tutup. (0.162) and negative and 0.058. 0.058. Satu menaik, satu menurun lah.
Oi.
Adilah ambil tong Ustaz Adilah, tong biru tu, kaca maribu tu Adilah. Tong biru atas tu. Yang atas tu je, satu tu je. No atas tu. Yang tu je. Dia tutup balik. Rosak ikut. Okay, we may continue another one. This is cycle number 7. We may stop right now, or we may continue for another one cycle. Okay, let's continue another one. Distribution number 8. Okay, carry over 0.13. Here 0.13. 0.156 divided by 2 is 0.078. 0.192 divided by 2 is 0.096. This is 0. Okay, then the last distribution, it is 0.096 times 0.625. We get here negative 0.06. 0.0 negative 36 and 0.078 times 0.769 is negative 0.06, negative 0.018. So this is the last one. Okay, we must stop at distribution. So we must find the end moment. End moment M naught. Okay, we have to total. Calculate the total. Start from FEM. Okay, calculate all the value. Okay, all the values start from FEM until the last distribution. Until the last distribution.
Asyik boleh tak sambil yang bibir nak saya punya tu yang saya buka tu dia dekat pipi.
Okay, until the last distribution. So start from 45. Okay, 45 plus 17.3025 plus 5.407 minus 2.079 plus 0.65 minus 0.4165 plus 0.13. Okay, it is 65.99. 66. It is 66. 66. 66. Okay. So next we will calculate the end moment for BA. Okay, start with the first distribution. Okay, start with 90 minus 34.605 plus 10.814 minus 4.158 plus 1.3 minus 0.833 plus 0.26 minus 0.06. This is 62.7. 62.7. Okay, for BC, it is negative 240 plus 150 plus 92.28 minus 57.675 minus 28.8375 plus 18.023 plus 11.088 minus 6.93 minus 3.465 plus 2.165 plus 1.333 minus 0.5 minus 0.4165 plus 0.156 0.4165 plus 0.156 plus 0.096 minus 0.036. It is negative 62.7. Okay, so MD is equal to 0. So this is correct. Okay, so we do the same for CB and CD. CB and CD. Okay, so we will do the same for CB, for CB, we will do the same for CB, CD and DC. Okay, this is for table number 1. Step 2A. Step 2A. Okay, I want to take a break first. I will continue this video. Okay, I will calculate the table, calculate the value, verify this table using Excel. Then we will continue to calculate R value. Okay, that's all for this session, 1 hour session. Thank you and Assalamualaikum.
Thank you.
Okay. Nanti sambung tak boleh celik mata dah, letih. Aisyah. Tak mau. Okay, lepas kita sambung balik, macam mana nak analyze R tu, R dengan R prime. Macam mana nak analyze R, lepas tu Kita akan continue dengan part 3, bukan part 3, step number 3. Step number 3 tu I will show to you how to analyze FEM due to delta prime. Kita kena buat assumption, and then kita akan, from the assumption that we made for one member, we will calculate the remaining FEM for other member. Okay, so yang paling complicated dekat frame analysis is part 3A, part 3A. Okay, so basically kalau dah 2A and 3A. Okay, 2A and 3A. So FEM tu dua-dua dekat part situ. After that 2B and 3B. Lepas tu step apa tu lagi, 2C and 3C. Step dia similar, sama je step. So yang payah pun dekat step 3A tu, FEM due to delta prime. FEM due to loading tak apa, sebab kita pakai formula given, formula FEM yang biasa tu lah. Okay, except yang 3A sebab kita kena made assumption. So yang tu yang the complicated part dalam frame ni. So yang tu saya akan tunjuk lepas ni lah. Lepas ni nak take a break sikit, nanti saya sambung. Okay, so thank you. Assalamualaikum warahmatullahi wabarakatuh.